afternoon, everyone. Some of you had the sodium potassium pump on our exit ticket as something that was a little bit confusing to you. And the book does go ahead and explain a little bit, but I just wanted to go ahead and do an overview because I really couldn't find one online that just really simply explained it. So here's a wonderful little picture, and you can go ahead and see that this is a phospholipid bilayer. Again, remember the phosphos, these guys are hydrophilic, they're water loving, so they're going to turn toward water. This is extracellular fluid, so this means on the outside of the cell. The lipids here, both these little legs here that are coming off of the phospho, happens to be hydrophobic, which means it is afraid of the water, so it's turning toward each other. So loving toward water, loving toward water. This is inside the cell, this is outside. And what the sodium potassium pump does is it kicks out the sodium and brings in the potassium. And we haven't really gotten to why this is important yet, but it's vital when it comes to how your neurons work, how your muscles work. What it's doing is setting up a gradient. Higher concentrations on the outside and lower on the inside. So that's going to go ahead and create this desire for these molecules to want to come into the cell. So down the line we're talking about action potentials and nerve impulses. This is very, very important. So the way the cell does this is by investing energy. The moment you invest some energy, that means that this is an active transport situation. We look at ATP, and we know that this is our little energy-carrying molecule that came from the mitochondria. I'm inputting ATP in order to change this protein molecule. So this big green glob here happens to be one of those proteins that embed itself within the membrane. On one side, you can see that there's 3 little compartments for sodium. This is simply a chemical reaction. The chemical sodium, the ion, actually has an affinity, a desire to want to be attached to that. The moment that the ATP is attached and becomes ADP, which means it's simply losing here a phosphate, it changes the way it's opened. Kind of think of this as a mouth. This mouth is open this way. The moment that you put the ATP and this little phosphate sitting here, it changes its shape. So at this point, it's going to spit out the sodium. At the same moment, it's allowing these 2 new sites to be active. These have an affinity to the potassium. 2 potassiums will sit in. The moment this happens, it changes the configuration again. It makes the phosphate come off and opens the potassium pump back toward the intracellular part of the cell, or the cytosol. So that's all it is. It's this investment of energy to take 3 sodiums and put it out, and 2 potassiums and bring it in. And what you're creating is more sodium outside of the cell than inside of the cell. And eventually, that sodium is really going to want to come inside of the cell. So simply setting up that potential. So for now, that's all you really need. I hope that really helped you guys out. If you have any other questions, make sure you guys just go ahead and email me at any point. Thanks so much. Bye.